Good. You are sharing area. Yes, good. Then I am going to, excuse me 1 second. Byron got Irish potatoes, which is a kind of candy. So I think I'm going to go out, take my mask off and have one. So give me 1 second, I'll be back. It has cinnamon. Yeah. It's like coconut also, yes. Irish candy cannot have coconut in it. It is impossible. There's no coconut in Ireland.
Well, doesn't mean it could have been imported and like they made this.
Doubtful. No kind of Irish candy can have.
You're not allowed to.
Coconut. Okay. So again, in answer to Joe's question, we have the E system. The question is I said that N1s and N2s are identical to T1, T2s. EK, TK, NK, right? So far you understand. So this is the setup that UK, I mean U1, let me have a look. Byron has printed oh, it looks very beautiful. Can you see this? This is the tri-cylinder. Yeah, the ones on the axes are the intersections of two curves.
Yes.
It cannot be Irish if it has coconut.
It's
Or cinnamon. Neither of the two things grow in Ireland.
so this is not Irish. This is American.
Okay. Neither coconut does grow in the US. As far as I know, cinnamon doesn't.
I mean, cinnamon is a spice.
But no, this is
It's the bark of a tree.
Yeah.
Cinnamon is the bark of a tree.
Spice. Like, yes.
Yeah, it's considered a spice.
I'm trying to say it's like very common to be found. A lot of it, even if it doesn't
Grow there. Okay. Yeah, this is incidentally, this is the intersection. This is a tri-cylinder which are circular. Tri-cylinder which are elliptical will not look so nice. It will be a bit, bit deformed.
So I was printing something else and I was doing a test run on I was mixing resin. So that's nothing to do with like it itself.
Okay.
But it's a very nice thing.
Do we want more? Because that's like somewhere between the range of like $2 at the most. So
then why don't you try to print the elliptical one with your A and B?
Because I didn't think of it and I've been running around a whole bunch. Also, there's a lot of the space I have for printing. I need to make sure people aren't in because the resin itself is toxic.
I see.
And as you print it aerosols, and it's also temperature sensitive, so I can't just throw it in my garage.
I see.
So it has to be in the house, and my house is not well
equipped to handle this. Okay.
It's not well equipped. So like I can print it, but like I want to print like maybe once a day or once a week, and I also need to make sure that was exactly what you wanted it to look like. I can try and
the elliptical ones will require the code to be changed.
I know I found that one. I'm just trying to resize it, but what was it? Maker Muse, I think August or Agus is his name?
Angus.
He showed it. He essentially did a small walkthrough, so I could actually generate those electrical cylinders. And on my, I'd like, the software itself is free and you can actually do.
No, no, that I know. But he already has printed elliptical cylinders? I don't think so.
I don't know, I don't think so.
No. 1, 2, 3, 4. Edges over here, then 5, 6. 5, 6, 7, 8, 9, 10, 11, 12.
It's another side.
Yeah, another 12. 12 times 2 is 24. And vertices 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 10, 11, 12, 13, 14. Yeah, 14 vertices, 24 edges. And now the faces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I got lost count.
So
1, 2, 3, 4. There are 4 at the top, 4 at the bottom, 8, 9, 10, 11, 12. Okay.
The way I, because I was having trouble, because when I counted the faces, I didn't have it physically to hold yet. So what I did is, there's a picture that shows pretty much where every cylinder cuts.
Yes, yes, and you can also rotate it. The one that I sent from the one, actually, Professor Weber sent you the SML file.
I did. I sent the STL file. He
Yeah.
sent a program so we could all.
Yeah. Yes. It would be. Sorry.
It finds dropped.
Okay.
Actually, I lost it for 3 days.
Okay.
I put it in the drawer and it dropped into a drawer. And
It's not plastic, it's a resin.
it's a resin.
Okay.
I mean, like, we can, well, we've done it. But, like, I don't know if you want to remelt that, because I think it's gonna, you don't want to heat that up. I would not heat those up. Unless
I mean,
you-
I'm not talking about this particular.
Anyway, where was I?
You know, maybe not.
I have, where's the math club? It's still pending?
The math club now has to be an unofficial math club, so the paperwork was filled out.
Yeah.
But, either something happened on the back end and there wasn't an official sponsor, even though we put Professor Weber down. I don't know what happened. I went and talked to them today.
Yeah, but Professor Weber's name was there?
We put in his email address.
Yeah.
Is Max, is Max on there? So,
Yes.
I can't-
Max? Can you hear?
Yep.
Yes.
So what happened was, I don't know why, but for whatever reason, it looked like we didn't have a sponsor for the club. And so we put in all the paperwork on March 3rd, but none of it got processed. And when I went and talked to Ms. Weaver today, she said it wasn't possible to get the club started. But what they did do is they had me sit down with the student body representative, and he said that pretty much all the functions we would have done in the back end, the student body can do for us. And so I know one of the main things we want to do is get supplies like that made and get a little drive like that. So they said they could put out an announcement and help us run it like that, and we can still meet as like an unofficial club. There's no official sign up, which is a little irritating.
Yeah, but why don't you write a joint email to me, Professor Weber, and Professor Huntsing, and to Arash and Max, so that to see where exactly we can go with this.
Are these considered?
Yes.
Yeah.
Just to
Because the two edges intersect over there.
just to the way, for instance, they're very flat.
No. Well, I mean, I can. But like, if you look at like here, it exactly looks like a circle.
It
Yeah.
almost hits a circle there. Yeah. So there's like.
No, the cross section is not a circle, actually.
It would, I don't think.
Well, no, if you face the intersection of the.
Yeah.
Is so.
Even
let's
then.
say If we.
Oh, yes, yes, yes. Yeah.
Yeah.
Part of a cylinder, it has to be a circle, and it rolls. Because of that, it rolls.
So
No, let's come back to this, and we will do that later. Okay. So U1 is equal to epsilon 1, this is the function of x1 up to xn. U2 Un is epsilon n of x1 up to xn. These are the functions. So let me give you a specific example. The specific example is, and these can be inverted. So you will also get x1 is equal to c1 of u1 up to un. x2 is equal to c2 of u1 up to un. xn is equal to cn of u1 up to un. So a specific example, u1 is equal to x plus y, which is the same thing as u1 of xy, and u2 is equal to x minus y, which is equal to u2 of xy. Now this is very easy to solve. So this is 1, 1, 1 minus 1, xy is equal to u1, u2, right? That's what it means. So you can solve it very easily. I'm not going to go through the process. This x will come out to be half u1 plus half u2, which is c1 of u1, u2, and y is equal to, oh, I should have called it x1 and x2, but never mind. Half u1 minus half u2, which is equal to c2 of u1, u2. Okay? So, if the grid lines for the xy system are x is equal to constant and y is equal to constant, that you know. And the grid lines for the x plus y is equal to constant look like this. This is this, for example, x minus y is equal to constant 0, x minus y is equal to 1, minus 1, etc. And the other set is like this. This is an orthogonal system. But if I took the equations to be not these but something else, like u1 is equal to 2x plus 3y and u2 is equal to 3x minus 2y, then the lines will be at an angle, the grids, lines. So then it is not orthogonal. Okay? So note that at any point you have two grid lines crossing. So you have, if you draw these are flat, so the tangents should be along the flat. So this will give you one basis, this is the t basis. But at another point, you can consider the normals to these lines. So this is normal to that line, and this is normal to that line. So this is an N1 and N2 basis. Okay, do you see that? So in your case, you will have x1 is equal to a1 cosine theta, a1r cosine theta, x2 is equal to a2r cosine theta. And you have to solve these two equations, sine theta. You have to solve these two equations for r and theta. And the thing worked in the notes is this is r cosine theta, y is equal to r sine theta. So even though I'm using sine r and theta, these are not the same as these. How do you solve these? From this you get x squared is equal to r squared cosine squared theta, y squared is equal to r squared cosine sine squared theta. You also get x over y, y over x is equal to tangent of theta. So if you add these two, you get x squared plus y squared is equal to r squared cosine squared theta plus sine squared theta. And here you get y over x is equal to tangent of theta. So this means x squared plus y squared is equal to r squared, and y over x is equal to tangent of theta, which means that r is equal to square root of x squared plus y squared. And here theta is equal to arctangent of y over x. If r is equal to constant, that means x squared plus y squared is equal to constant. So the grid lines over here are simply circles. And theta is equal to constant means that you have a straight line. So these spokes, but this is an orthogonal coordinate system because you see the tangent to each of these, they're perpendicular, and this is normal to this line, this one is normal to that line. So the T and the N systems coincide. And T1 dot T2 is equal to 0. N1 dot N2 is equal to 0. That's what says that they are orthogonal. Joe, do you see it?
Yeah, thank you. That's what I was thinking it was.
Yeah. And this happens in n dimensions also. There's an n-dimensional, three-dimensional problem of this kind, which is actually on the problem set. Okay. Who are present? I can't see. Riviera can't come on Thursdays. Byron is here, so very few people are here. Yeah. I can't see all the people because on the side there's only a limited number. Is this part clear? So now you have to show that in your case it is obviously not going to be perpendicular, quite impossible. Okay, because and you have to just do for this situation exactly what I'm doing over here. And I sent an announcement already. Yeah. Indicating what you have to do. Is this clear to everyone? Has anyone done this? No?
Yeah.
Who said yeah?
Yeah, me.
Okay, you have done this.
Yeah.
Okay, did you get the ellipses and the spokes?
No.
Yeah, but you have to.
Say it again, the ellipses and the spokes?
Yeah, that means those are the level curves.
Yeah, I didn't do the level curves yet.
Yeah, well, you have to do the level curves. So the level curves calculation, this is done in the notes. So this is exactly like this, but rather than these two equations, you have these two equations. Clear to everyone? But the work is almost essentially the same. This is your basic weakness in basic algebra. That means you can't solve equations, you don't know what to do. So that's the problem. So unless basically we are doing something very simple, except that there are no recipes over here. That is, the equations can be arbitrarily complicated and you have to use your heads to see where it leads. Okay? Any questions at this stage? Okay, so everything you should be able to do, except maybe to find ds squared and to find the expressions for gradient, divergence, curl, and the Laplacian in these new coordinate systems. So for instance, if I have a scalar field, let's say, so phi sends xy to x plus y from R2 to, oh, sorry, this is wrong. P is xy going to xy comma x plus y from R2 to R2 cross R. That means at each point I have a number. So this is a scalar field. So we can think of this as the specifying the temperature. So at the point 1, 1, the temperature is 2. At the point 0, the temperature is 0. At the point 1, 0, the temperature is 1. So this is a map of the temperature. Okay, so now how would I write this in the r theta system? So phi, so x plus y will be equal to r cosine theta plus r sine theta, right? So phi, not phi, but we have to call it, give it a different name because it's a different function. So the description of the same field in the r theta coordinate system would be T, which is equal to r theta going to r theta, comma, r cosine theta plus sine theta. And now we have to be careful. So this goes from 0 to infinity cross 0 to 2 pi. So the field now will be specified everywhere except for the origin and the x-axis. Is this clear? So all this is fairly trivial. What is going to find the expressions for the gradient, divergence, etc., that's going to be more complicated. Because you have to, but what is the divergence in this case? The divergence of a vector field is going to be, for instance, what is the gradient? The gradient is going to be the vector del x phi, del y phi. So phi depends on xy and del x also depends on xy. So you will have to, this requires that you use the chain rule to get the correct expressions. And that's tricky. So what is del dot phi? No, sorry, not phi, but some vector field. So divergence of some vector field beta, and beta, let's say, is xy going to xy, beta 1, beta 2, or beta x, beta y, from R2 to R2 cross R2. This will be equal to del x beta x, del y beta y. Now, to convert that into the r theta coordinate system is a bit difficult. Not difficult, I mean tricky. You have to use the chain rule over and over, and so that, clear? Okay, now I have two integration problems. I think you had better lie down. Your eyes, 38 hours of no sleep is not a good idea.
Oh, no.
But obviously not enough. It's not enough. You can see just that you are almost asleep. Okay. So the next thing, you have, each of you have a path along the sides of a four-dimensional cube. So I had drawn a four-dimensional cube last time. I will draw it once more. So someone may have this path. This, then go here, then there, and then back along the principal diagonal. This is the point. Oh, no, that's wrong. Sorry. Yeah. Anyway, you have to go to the this point. But your paths are all have four pieces. And this requires that you parameterize those paths. So parameterization of a straight, these are all straight line segments. Parameterization of a straight line segment is extremely easy. Suppose you want to go from this point to this point in Rn. This is B1, B2 up to Bn. This is A1, A2 up to An. What is a parameterization? So you have x1 is equal to A1 plus T times B1 minus A1. x2 is equal to a2 plus t times b2 minus a2. Xn is equal to an plus t times bn minus an. You note that if you put t is equal to 0, t is equal to 0 gives you x1 is equal to a1 plus 0 times b1 minus a1, which is equal to 0. T should be thought of as time, so at time t, you will find that you are at that point. Okay? Whereas if t is equal to 1, you get x1 is equal to a1 plus 1 times b1 minus a1 is equal to a1 plus b1 minus a1. These cancel, giving you b1. So at time t is equal to 0, you are at the initial point. At time t is equal to 1, you are at the final point. So all the straight line segments should be parameterized like this. Now, can you tell the second problem, which is 3C, has the shape of a cut of a pizza or a cut of a pie. So all of you have, can you tell me the angle? Can anyone look up the angle for the problem number 3B? And while you are doing that, I will go and have one more candle. Thank you. What does 3B have? What are the angles? Can you tell me for the circular piece? Oh, it's on your iPad. So we'll have to save us. I mean, I suppose I can look it up, but I don't want to do anything to spoil this. Does someone have it on the phone?
I have 12-factor authentication every time that I want to log in.
It's so upsetting. I'm not sure if no, I'm not gonna do those files right now. So I have a problem is that I save half my files on my computer or on my hard drive until I get the.
Can you go into Canvas?
Yeah, we're on Canvas. What we're planning about is we have to log in. We have to do a two-factor authentication before we can get into
I see.
Canvas anymore.
Yeah, so yes, that's true. Who has access to Canvas easily?
We're
I do.
Exam 2B. No, 2A.
2B.
2A. 2A problem 3B. Just tell me what the angles are. It's 2 pi over kn or some such thing.
It's 2 pi over n.
2 pi over n. No, there has to be a k.
Oh, it's k over 2 pi over. It's k 2 pi over n.
K times 2 pi over n.
Yes.
Plus,
Plus
and
pi
the other
over n.
one? No,
The,
yeah, just the
other
angle.
one is k plus 1 2 pi over n plus those are the two.
Pi over 4 plus k times 2 pi over n. And the second one is pi over 4.
No, the two. This is.
Let me have a look.
So there's
So it's this one.
K times 2 pi over n plus pi over 4. No, that's the second point is k plus 1 2 pi over n plus pi over 4. Okay, yeah. So k plus 1 2 pi over n plus pi over 4. Okay, so this is the angle pi over 4, right? So from that, you go k plus 2 pi over k times 2 pi over n, which will be somewhere over here. Okay, and then you go another 2 pi over n, which would be somewhere over here. You don't need to draw this line. This is for pi over 4. So this is O, this is A, this is B. So you go along this path up to A, which is a straight line. You come back along this path, which is also a straight line. This is a part of a circle. Okay, and over on AB, x is equal to, the parameterization is given actually. It's, I forget, r or something. What is the, you go unit distance? Yes, because the circle, this circle is of radius 1.
Yeah.
So 1, yes. So it is x is equal to cosine of whatever that angle is, pi over 4 plus 2 pi k times 2 pi over n, and y is equal to sine of pi over 4 plus k times 2 pi over n. That's the first point. So this is the value of theta, and plus 2 pi over n is the other value of theta. Okay? So you have to go up, then turn, then go down. And you have to integrate a vector field along that. K is different for different people. And n I have specified. N is, I think, 2 times the number of people in this class plus 1. Or some such thing, I don't remember. Okay? N, sorry, n is that. Is this clear? And the 3c is a line integral also, but 3c is in n dimensions. So I will say nothing about that. So all of you should be able to do 1a, 1b, 1c, 2a, 2b, and 3a, 3b, 3c. That is 17 plus 17, 34, plus 12. That is 46. For some reason, I counted 41. So maybe there are some other.
Well, on 1C, because I think you just added 3C to what we said we could do.
Yeah.
And you said we can only do, or maybe it was
3C, you should be able to do. It's very easy. Any questions at this stage? No?
I did find someone made a tesseract. I put that STL inside of the.
Oh, but you can't make a tesseract in 3 dimensions. That is impossible.
Well, like not an actual tesseract, but like the same way as you drew.
As I
something.
drew it, yes.
Yeah, they made a tesseract that looks the same way of just like lines pointing to. So like a cube with a cube and the
And lines, yeah.
lines.
Yeah, but there's a video that I will send you which looks at R4 from the perspective of, looks at a 4 sphere from the perspective of 3 space. I haven't had a chance to send it. You had better recruit people from the other sciences.
For
the math club.
Oh, yeah.
This is the kind of thing, give that to me. Yeah, this is the kind of thing, I mean, in an ideal situation, I would assign you each a separate thing. And then if I were teaching this class, you would have to understand the geometry. If I were teaching dynamics, you have to work out the dynamics, at least experimentally. I mean, this can be twirled. Do lots of things. I mean, it can be rolled. It can be made to behave like a top. Yes, yes. And all that you can actually, yes.
So
How long it will wobble? I mean, I remember when I first took my classical mechanics class in Carnegie Mellon, very strangely, his son lived on the same floor as me. I didn't know. So, I beg your pardon? No, not Carnegie. I mean, my physics professor's son. Yeah. So I had cooked Indian food, and so he had come out of the lift and he passed me and said, so I see, so this is the apartment from which those good smell of food come. So I said, yes. So then we talked and he said, I said, I went to Carnegie and said, my father was a physics professor. So I said, what was his name? And so he said, Professor Kisslinger. So I said, well, I took classical mechanics from him. So, that was when I got fed up with physics. So I almost got a PhD in physics first. Then I just I thought that I would have a PhD, but I will not believe a word of what I have done. So I went over to the mathematics department. Yes, because the calculations, I could do the calculations. I thought, I mean, my view is that it is basically not correct.
So a lot of the way when you get plus physics, you don't actually know the math.
Yeah, in this case, one still doesn't know why those recipes actually work. So I couldn't get a PhD and not be of the opinion that what I've done is actually probably wrong. No, I didn't.
There's a lot of things we do.
No.
Are you telling you don't?
No one, there's nothing depends on the. We have a better answer to that question than the properties of particles in particle physics. Or anyway, but we are getting far. But anyway, the point that I was trying to make is that we were given this problem, a top without a bottom, which looks like this. So the top does not have the nail, and the top was spun, so it fell on the floor. And Professor Kisslinger asked us to calculate how long it will wobble before it falls. So that was one. Then there was another problem in which there was an ellipsoidal planet with a dumbbell-shaped satellite in its field. So something like this, with something like this rotating around it, and you had to calculate its orbit, etc. So the dynamics is very interesting. There's a Felix Klein, who was a very famous mathematician, along with Arnold Sommerfeld. Sommerfeld was also a very famous physicist. They have a book, 4-volume book on the motion of the top. So in dynamics, I will send later to the general, all the STEM majors, papers that describe the motion of the oloid. Max, are you there?
Yes.
Okay. I have found 2 papers, one written in English and one written in Russian. So in the Russian one, I can understand the mathematics. So will you be able, I will send it to you first to see if you can understand the abstract. Okay? Yeah. Okay, so now, anyway, so these things have strange applications. For example, this tri-cylinder business, there are certain kinds of bacteria called cyanobacteria, whose core consists of tri-cylinders. And So the tri-cylinder must somehow help with maximizing light harvesting in photosynthesis. We do not quite know how it works. So something this odd actually occurs in microscopic in the microscopic world. You know, the ellipse is defined to be a curve which it is the path traced out by a point that moves in such a way that the sum of its distances from 2 points remain constant. A circle is the path traced out a point such that its distance from a single point is constant. Okay, so you put a pin over here and you take a pencil you tie the string here and you have a pencil and you hold this taut and then you go around. That will draw a circle. If you put 2 pins and tie a thread like this, if you hold it taut and go around, you will describe an ellipse. So if the difference remains constant, that's a hyperbola. And Maxwell, James Clerk Maxwell, from Maxwell's equations, he actually devised these methods of drawing these curves. So if rather than the sum of the distance, you had the product of the distances a constant, in that case, you get what are called ovals of Cassini, which look like this. For certain values, then there's one that is like a figure of 8, and then for certain values, it separates into 2 ovals. These ovals of Cassini are also used to design surfaces which act as fungicides. So they kill fungus. So I'm going to send you these things because you need to know that these are used. These strange things are used actually. So the paper that I already sent you develops the DNA structure, and the DNA structure, I have a packing paper also, how to pack spheres the most tightly. Now, I already sent that to you. Not yes to everyone, to all the STEM majors. There's a little video on packing. There was one on packing, one on minimal surfaces where this guy dips things into a soap film. And actually, a cube wire in the, a wire cage in the form of a cube, when he dipped it, what came out, the minimal surface corresponding to that actually looked a bit like the picture of the tesseract that I draw with soap films. I don't know if you have had a chance to look at these. These are the things that should be discussed at the math club. And you should understand that this is how science proceeds, actually. I will also send you 3 pieces written by very famous people. The first one is written by the most famous of them, or no, the first 2. The first one. It talks about the unreasonable effectiveness of mathematics in the natural sciences. That was written by Wigner. Professor Wigner was at Princeton, and he died before I came to the United States. I'm sure of that. And Professor Gelfand, actually, I saw him when he was 93. He gave a talk at Penn. And Professor Gelfand always talked about the unreasonable ineffectiveness of mathematics in biology. So but one collaborator of his, who is at Rutgers, I think, wrote a paper on this, with which I completely disagree. And there's another paper, which is called The Role of Mathematics in the Solution to the Fundamental Problem in Biology, the Puzzle of Life, what it means. Okay, so what I wanted to tell you is that geometry is the ideal for all the sciences. In geometry, we have axiomatized it, which means we can deduce all the results. Which means we have no reason to observe in order to see if something is true or not. But this happened after thousands of years of observation. But the point over here is that we still have to observe to make conjectures as to what is likely to be true. So for that, we need observation. But in order to establish that it is true, we don't need any measurements or anything. We prove it. So this is the form of a mature science. Okay? There's a very problematic move now to directly make computer simulations which will never discover the physical laws, because one pretends that one actually knows how these things interact, which one doesn't. So the simulations are not going to tell you what the underlying structures are. So this is very important to keep in mind. One should never fall into the trap of thinking that a computer simulation is actually the reality. What I find in the US, I find a tendency in the US which I consider extremely dangerous. That is to forget about actual life and live a virtual existence. As a result, one is becoming less and less human. One doesn't know how to interact with other human beings. And then soon one will have robots as companions. It is extreme in the US. Nowhere else in the world it is like this. I see, it is unthinkable that at a coffee shop, the people are sitting, each with some sort of device. No interaction of any kind at all. It might as well be a graveyard. No. There's complete lack. No, there's certainly there are cyber cafes. That's a different thing. But not all cafes are cyber cafes. If something goes and removes human interaction, then that essentially is a graveyard. No. No, I go to Japan every year. The US, this deadness is absolutely characteristic of the US. Japan has other kinds of problems, of course.
Not making babies.
Hmm?
Not making babies.
Average age of people for drinking that is so much higher than the US.
Average age of what?
Average age of fertility in Japan is much higher than the US.
And what is the standard deviation?
I don't know.
Well, that's exactly the point. So this statistic you again gave the first moment, which gives no information at all. So obviously the brainwashing coming from that silly course is stronger than whatever I told you the other day.
So
Specifying one moment does not tell you anything whatsoever about a phenomenon. And the mean that you just gave us is just the first moment of the distribution. And if the average age at which one loses one's virginity is higher in Japan, what effect can it have on the rate of the production? Yes, the two are independent of each other.
Yes.
Human what?
It's an
Human,
indication of how
not clear at all. Not clear at all. In most Islamic countries, men and women are completely segregated.
awful.
No. But what I'm saying is that does not mean that the rate of babies born in Islamic countries is lower. So obviously, this particular statistic has nothing whatsoever to do with the phenomenon. So this is exactly what one sees in these silly newspapers, where journalists who understand nothing whatsoever like to appear scientific by giving one number. This is one of the problems of our times.
It was actually that number.
Well, the conclusion is invalid. This is why you should take 251 from Professor Hunsinger to be cured of this.
Just to see all the
Okay. Oh, yes, plenty of sections.
I'm not taking any credits here this semester, but I like comparing on it stuff.
Okay. Okay. So I think how many of you have seen this? I mean, have you shown it to anyone else in the class or no?
I sent a picture of it.
Yeah.
And yeah, I can make a couple. I was wondering if you thought that was good.
Of course, it is good. But I mean, try to do an elliptic one. That would be more interesting.
I was actually looking at how to do that right now. I can find how to make a cylinder, a three-dimensional. I don't know if that shape would be called a cylinder.
An elliptic cylinder.
An elliptic cylinder.
Yeah. You can consult with Angus.
I actually might be able to send him a message and be like, hey,
Yes.
I'm in this class. If I can find out how to make one of those, I can make a tri-cylinder with tech because the modeling 3D modeling software has these intersections. So
Yeah.
I was actually looking into that right now and seeing if I could do it. Because if I could,
Yeah. Did everyone see this? I mean, is it?
I did post a picture of it on the Discord, and people do have access to the STL file to look at it. So.
Yeah. So I mean, I gave you the problem of finding the volume, the surface areas of the faces, and the lengths of the edges. In this case, all these are the same. Yeah. No, but yes, they're all the same. Yes.
So the edges are all.
Oh, actually, no. Maybe these two are same and these two may be different. I don't know. Because I didn't calculate it. I just know how to calculate it. I didn't actually carry out the calculation. But the edges must be the same. Yeah. And then I asked you to, I also made it into a graph theory problem. So this is the South Pole, this is the North Pole. And in your situation, this is not as symmetric. So the question would be, what is the path of smallest length from the South Pole to the North Pole? Yes, because the ABCs are different. And so these will be slightly bent over. It's not completely asymmetric, but it will not be as nice as this one. It will still roll. The reason Angus may be interested in it is that it will still roll.
Well, he might. I recently saw that he was losing interest in general 3D printing. He was actually going into more digital stuff, as you said. People. So it's actually because that video I believe this was 7 years ago.
I have no idea.
Yeah.
But there are infinitely many objects of this kind. All you have to do is to go to Math World, Wolfram Math World, go to algebraic surfaces. And then click on, so for each value, so you will see for the quadratic, for the cubic, for the quartic, quintic, sestic, etc. Just
you said it was in Math World.
Algebraic surfaces. If you click on those, you will see pictures of minimal surfaces, and they are remarkable. The oloid. The oloid looks like this. It's a circle in that plane and a circle in this plane. Angus has an oloid printed out. And it's the convex hull of that, which looks like this. That rolls. And that surface actually has a 6th degree equation, if I remember correctly. So ideally, I should assign each of you a different thing and make it into a 271 partly calculus 3 partly graph theory problem. Okay. But incidentally, our graph theory had only vertices and edges, right? But there is a hypergraph where you can add more cells. So these are 2 cells. Okay, so you've just seen the tip of the iceberg. Anyway, so, and then the oloid, there's the oloid, and then there are things called sphericons. I also sent you videos for those. But these geometric objects have come up in actual, in nature. So they are very, very interesting. Any questions? No one has any questions? Okay, so I think in that case, let me just think very carefully. I already made the announcements about the exam. I already gave you whatever I was going to say about the exam. Okay, now it is your job to calculate. So I think your time is best spent in doing the work. Okay? Any questions at all? No, yes?
No,
Okay.
Max.
Well,
Joe.
Max,
Yep.
any questions?
Not really.
Okay, how many did you do?
I didn't do any yet.
Oh, you did not do any yet.
No,
But do you sort of understand what is going on?
not at all. I read the notes and I still can't understand anything.
Then you must have a question. Or your understanding is at such a stage that you can't formulate questions.
Yep.
Okay, no, what you should do is to take the problem that I've assigned you, have the notes open, and try to mimic the calculation. That will force understanding upon your brain. Reading the notes will not give that. In other words, you have to directly engage in the matter. So
No,
that's the rest.
I tried to mimic and I was doing 1A I, the first problem of 1A, and I think I still did it wrong, even while trying to mimic it.
Well, this procedure needs to be repeated until you get it. What happened to Joe? Joe left?
No, I'm right here.
Okay. Did you do 1A?
Yeah.
What about 2A?
Yes.
Okay. Joe did all of them?
I did 1A, I did 2A, 1B, and then I think I just finished 2B.
Okay, that's not bad.
That's right.
So anyway, you are making progress. So who finished 272?
I finished 272.
Oh, very good. And
That's tonight is finished that.
yeah, 272, the sooner we finish it, the better. 272 has now, I mean, it's very, I mean, the algorithms are a bit irritating, but it can be done. Okay, so I will stop there. And you can always send me questions if you have any. And then I will answer. Okay? Okay, very good. So since there was movement and since there was candy eating today, I think the lights didn't go out. Okay. Very good. So I will see you next Tuesday. When is the exam due? Next Monday. Okay. Okay. So good luck. So this is the last exam which has no solved exam. Yeah. 2B and 2C have solved exams. Okay. So I will end the meeting now.
Thank you.
Okay. Bye-bye.